Good morning, students. I am going to start the class. Today, I am going to start the new chapter, that is mechanical properties of solids. This is our chapter name. It is a small and important chapter. Now, you listen very carefully. I am going to start. Is my voice clear, students? Yes, na? Okay, starting the class. Write in the chat box if you have any problem. Right, let us start. Okay, mechanical properties of solids is our chapter name. In this chapter, what we are going to discuss? We are going to discuss about the properties of solids. In that, first, I am going to explain the rigid body. What is rigid body? What is the definition of the rigid body? Right, rigid body means what? I think you know. Rigid means what? Strong, right? Then can anyone write in the chat box? Right, what is a rigid body? If the shape and size of a body does not changes, if shape and size of a body does not changes under the force, then such body is called as rigid body. Rigid body means its shape and size does not changes, right? Actually, there is no perfect rigid bodies. If you apply the force, okay, on the rigid body, even I will apply the force on the iron bar. Okay, it can bend if you will apply the enough force. That means there is no perfect rigid bodies, right? If you apply the force on the solids, then what changes occurs, that I am going to explain. And next one is the after the rigid body. Okay, I am going to explain the deformation force. What is deformation force? Deform means what? Deformation force means this force tries to change the shape and size of a body. Okay, the force which tries to change the shape of your body. Okay, the force which may change the body, or which may change the shape of a body, or which may tries to change the shape and size of a body, which tries to deform a body, right? The force which tries to change the shape and size of a body is called as deformation force. Deformation force, if you will apply, then it will be deformed, means its shape changes, its size changes. Okay, for example, you take a balloon, you apply the force on it, or otherwise you take a any other substance, any other rubber ball, anything, right? Or iron, you take iron bar, you take, and you apply the force on that, then its shape and size may be changes, right? it the force which tries to change the shape and size of a body is called as the deformation force. And the next one is the restoring force. Restoring force means on some bodies, if you will apply the force, it will deforms. If you will apply the force on certain bodies, it will deforms. But after the deformation, okay, after the deformation, some bodies will regain their original shape and size. For example, this is a spring. Okay, it is a spring. Or you take a rubber. Okay, little force you can apply on the rubber to stretch it, then it will be elongate, it will elongate. Then after this, right, if you release this rubber, if you release this rubber, what happens? The rubber will come back to its original shape and size, right? Then you are applying the force that is called as the deformation force. It will tries to deform the rubber, and now the force which is generating in the rubber, and it tries to bring the rubber to its original shape and size, right? You are applying the force on the rubber, rubber will be elongate, it is deforms, its shape and size changes. But after the deformation, if you release it, if you remove the applied force, right, at that moment what happens? When you will remove your applied force, deformation force, then after withdrawal of the deformation force, the body, some body will regain, the rubber will regain its original shape. That means some force generating inside the rubber, and it is bringing the rubber to its original shape and size. That force is opposite to the applied force, deformation force, right? Because it should come back, this rubber should come back to its original configuration, original shape and size. Such force is called as a restoring force. Restoring force is the force which tries to bring the body to its original shape and size. The force which tries to bring the body to its original shape and size. Original shape and size is called as restoring force. Is called as restoring force. Okay. For example, some force you applied. Okay. We applied some force at here. Even on spring also, if you apply the little force, it will be elongate. Okay. Helical shaped string spring, if you will apply the force, it will be elongate, but after the removal of the force, it will come back to its original shape and size, right? That is called as the restoring force. The force which tries to bring the spring to its original shape and size is called as a restoring force. Okay, look at here. For example, if this is a spring, okay, you take this as a spring, and if you will apply the force this side, and the force which tries to deform a body, that is called as the deformation force is this side, but some force generated inside the spring, and it will try to bring the body to its original shape and size. That force is called as the restoring force. Okay, and now the force which tries to bring the body to its original shape and size is called as the restoring force. Now, for example, body elongates certain, this spring elongates, and it will come, it will be at rest, it will be at rest. If applied force is more, if applied force is more, then F is the applied force, right? If applied force is more, deformation force is more, at the moment it will be deforms, its length is increases. If restoring force is more, then it will goes back to its original position. But at equilibrium, right, at certain equilibrium, in case what happens, deformation force should be equal to restoring force. Okay, deformation force means applied force is equal to restoring force. Next topic is the elasticity. What is elasticity? What is elasticity? Elasticity means what? Elasticity means what? It is the property of who? It is the property of body by virtue of by virtue of which regain its original shape and size after removal of the external force. Okay, elasticity means what? Elasticity means the property of body. It is a property of body by virtue of which regain its original shape and size. It regains its original shape and size after withdrawal or removal of deformation force. Okay, after removal of deformation force or after withdrawal of deformation force. Deformation force is called as elasticity. Elasticity, elastic body. Okay, elasticity is the property of elastic body. What it will do, right? The property of body by virtue of which regain its original shape and size after removal of deformation force. If you apply the deformation force, it will be deforms. Its shape and size changes, but after removal of the deformation force, it will come back to its original shape and size. That is called as elastic elasticity. Elasticity means it will regain its original shape and size. Okay, and the next let us go for the some examples of elastic body. Can you give example of elastic body? Anyone write in the chat box? You write in the chat box. Give the example of elastic body. Elastic body means the body which has the elasticity property, that is called as the elastic body. Elastic body means it has the property of elasticity, right? And that is called as elastic body. Now, example for the elastic body is there is no perfect elastic body. Okay, then we could take a nearly perfect elastic body is nearly perfect elastic. Nearly perfect elastic we can example is quartz fiber. Quartz is the material that can be taken as uh, nearly elastic body. Okay, and steel, if you compare the steel, okay, if you compare the steel with the rubber, which is more elastic according to physics, right? Elastic means it exactly regain its original shape and size. There is no deformation, there is no change in the shape. Okay, steel is more elastic than rubber. Steel is generally you will think that rubber is elastic, steel is not elastic. Okay, but what happens at here, you apply the same force on the rubber and steel, right? In which deformation is more, change in shape is more, in which rubber, in the rubber change in shape is more. That's why rubber is not elastic because it's some deformation will be set in the permanently comparing with the steel, right? Steel is more elastic than rubber because steel deformation steel deformation is less. Deformation means change in shape. Change in shape, if there is no change in shape, that is elastic body. Always the body acquires original shape, right? Steel is more elastic than rubber because steel deformation is less than rubber. Okay. Next one. This is about elastic. Next, elasticity opposite word is the plasticity. The opposite word of elasticity is plasticity. What is the definition of the plasticity? The plasticity means it is the property of, same definition will be there. Property of body, property of body by virtue, due to that property, by virtue of which by virtue of which does not regain, does not regain original shape and size after removal of external force is called as plasticity. What you did here, you removed the external force. You removed the external force. Even though the body does not regain its original shape and size, the property of body by virtue of which does not regain its original shape and size after removal of external force. For example, you are applying the force on the putty. Okay, right? And example of plastic body. Example of plastic body. Example of plastic body is putty. Do you know putty? For the glass, to fix the glass to the windows, we are using at the edge putty, and to close the small holes, we will use the putty. Okay, or you take the mud. Okay, you take the mud, you take the clay, or you take the wheat powder, you can add with the water. Okay, and then after that, while making the chapati, we will apply the force on the duff, but after the removal of the force, right, that is object does not come to its original shape and size. Okay, example of plastic body is the putty. If you apply the force on the putty, it will deform, shape changes, but after that it cannot regain its original shape and size. That is the plastic body. If any object after removal of the external force, if object comes to its original shape and size, that is called as the plastic body. And if the object does not come to its original shape and size, that is called as the plastic body. That's all. It is very simple. Have you understood what is the plastic and what is the elasticity? Do you have any doubts? If you have any query, you write in the chat box. If you have any query, write in the chat box. Students, okay. Next, let us continue. What is our next topic? Next topic is the stress. What is the stress? How many types of stresses are there? That I am going to explain. You listen very carefully. Okay? You know stress, right? I think you listen many times the stress word, right? That I am going to explain now. What is a stress according to the physics? Okay, the stress is the stress. Wait for a minute. Stress means, for example, when your background is Hindi medium, now you change it into English medium, right? And you may some under the stress, right? Whether I can understood or not, what happens, what is going on, right? That is a stress. And now there is a mental stress. Then we are discussing about the physical stress. What type of stress will be there? Okay, what is the definition of the stress? When you apply the force on any body, if you apply the force on any body, that body will under the stress. Okay, students. Now stress means If you apply the any force on a body, for example, if you apply the force on certain body, this is a body, okay, rubber, let us consider. If you apply the force on this, what happens? You are applying the force on certain area. You are applying the force on certain area. This is the deformation force. In this also some force will be generated. That is the restoring force. Restoring force. If this restoring force and deformation force both are equal at equilibrium, right? बिट्टू जी 12 o'clock क्लास खत्म होता है अभी क्लास शुरू हो गया है now you listen it here deformation force and the restoring force are equal okay deformation force and restoring force are equal the stress definition is the deformation force per unit area or the restoring force per unit area that is the definition for the stress stress means restoring force per unit area in unit area how much restoring force generated that is called as a stress it is called as stress but this stress okay according to mathematical equation if you want to write stress is equal to be write as restoring force by area restoring force by area that is called as a stress stress is the restoring force by area now but at equilibrium the deformation force is equal to restoring force right now for example this is a rigid support here we are applying some spring here then here I am applying the deformation force to pull down in downward direction like this right this is the deformation force right this is the deformation force and now this side backward some force will be generated right when you will pull down okay when you will pull down it will come back like this right it will do the extension and then when you will release this okay then some force will be generated in the backward that is called as a restoring force restoring right restoring force but at equilibrium it is not going down not going up means this for deformation force equal to deformation force generally equal to the restoring force okay restoring force that means now we can write the mathematical formula for the stress like this also that is the restoring force by area the restoring force is equal to deformation force that's why we can also write as deformation force by area what we can write deformation force by area we can write deformation force by area we can write next let us go for the next one stresses how many types are there and what is unit SI unit of the stress is the force by area right stress is the force by area what is the SI unit of the stress write in the chat box students write in the chat box what is the SI unit of the stress force by area force unit is what Newton area unit is meter square Newton per meter square what is the dimensional formula right what is the dimensional formula for the stress dimensional formula means it was very simple to find the dimensional formula because we know stress formula is force by area you know force formula mass into acceleration mass is capital M mass into acceleration by area we can write mass is capital M acceleration is the dimension formula is LT power minus 2 and area dimension formula is L square you know this one ml inverse t power minus 2 we will get is it right And now next one is the types of stresses. Stresses are three types. Okay, these are three types. Sorry, these are generally broadly two types. Okay, but if you will reclassify, then it will be three types. Okay, I will explain only two types. These are two types. Okay, two types. And the first one is the normal stress, and the second one is the shear or tangential stress. Shear or tangential stress. Then what is the normal stress? Normal means what? It is perpendicular to surface. If the stress is perpendicular to surface, that is called as a normal stress. If stress is perpendicular to the surface of a body, okay, if stress is perpendicular to the surface, then it is called as normal stress. Then it is called as normal stress. Okay, this is about normal stress. Now let us go for the next continuation. Normal stress means this stress is always perpendicular to the surface. Otherwise, I will erase total. Okay. Wait for a few seconds to erase these all things. Right. Allow giving the unit of the stress force by area. That is a Pascal here. Pascal. Right. Actually, pressure unit is the Pascal. No? Pressure unit is Pascal. And this is also a force by area. This the unit of the stress is equal to unit of the pressure also. Right. Same. You can write that answer also. No problem. And now let us continue now. Right. Next topic is what we are discussing? Stresses. Stresses are two types. What are they? Normal stress and what? Shear or tangential stress. Then the normal stresses are means that stress is perpendicular to the surface, right? Stress. What happens? Stress is perpendicular to surface. Then such stress is called as what? That is called as normal stress. Normal stress. I will give the example where you will apply the perpendicular stress. For example, this is the it is a cylinder. Okay, and the cylinder has some surface at here like this. Here this is a surface and this is a surface, and you are applying the force right like this. I am applying the force like this. This side force I am applying. This is the force, and this side we are applying the force. You see here, this force is perpendicular to surface, right? This force is perpendicular to surface area, right? And this force is applied on certain area A. Then the stress is nothing but that force by this area we have to write. That is area on which force is applied. That is the stress. If stress is perpendicular to surface, then that stress is called as a normal stress. These are two types. Normal stresses are again two types. These are two types. The first one is the longitudinal stress. Second one is the one is the longitudinal stress, and the second one is the bulk or volume stress. Bulk or volume stress. These are the two types of stresses. Okay, right. Normal stresses actually. Okay, so let us go for the first type of stress. What is that? Longitudinal stress. Which stress is said to be longitudinal stress? What this longitudinal stress will do? This stress tries to change the length of your body. Okay, right. The normal stress which tries to change the which changes the length of your body or tries to change the length of your body is called as longitudinal stress, right? It is the stress which tries to change the shape of a shape nine. The stress which changes the or tries to changes the length of your body. Length of your body is called as longitudinal stress. If you apply the force longitudinal stress, then its length will be changes. Now longitudinal stress is equal to any stress formula is the same. That is a restoring force by area. Restoring force by area. Longitudinal stresses are two types again. These are two types. Okay. First one is the tensile stress. What this tensile stress will do? This stress tries to increase the length, right? Longitudinal stress means changes the length. Change in length may be that is a positive or negative. That means length may be increases or decreases. If length increases, the stress is said to be tensile stress. Longitudinal stress is called as tensile stress. If length decreases, that is called as the compressive stress. Compressive stress means this stress tries to decrease the length of a wire. Decrease the length of a wire. This will be like this there. For example, this is a rigid body. Okay, or otherwise we can draw like them like this also, right? Or like this we can apply. And here the force is applied like this is the force, and this force is perpendicular to the surface. And now here we are applying the force like this is the force and this is the force, right? This force by area, this is called as a longitudinal stress. And if the stress increases the if stress increases the length of a wire, then that is called as a tensile stress. Okay, if decreases means that is called as the compressive stress. Okay, clear students? Any query? If you have any doubt, you write in the chat box. Okay. Next one is longitudinal stress completed. Second type is what? Bulk or volume stress. Bulk or volume stress. Bulk or volume stress. If in the longitudinal stress, force here from the figure we can write force by area we can write. If this area is what is the formula? If radius of the wire is smaller, the area is in circle shape. We can also write like this: force by area is pi r square. We can write unit is Newton per meter square, right? Okay. Next one is the bulk or what? Volume stress. What is the bulk or volume stress? Okay. This is stress is nothing but force by area. Okay. Force per unit area. In this unit area, how much force you are applying? You follow the cursor. In this unit area, how much force you are applying? That force per unit area is called as the stress. Force per unit area is called as the stress. The stress changes the length means it is called as longitudinal stress. Stress which changes the stress which tries to change the stress. It is also normal stress. The stress which tries to change the volume of your body. is called as bulk or volume stress. Bulk or volume stress. Okay, this stress will tries to change the volume of a body. Okay, and this is about volume stress. And if you want to write the formula for the volume stress, then how you will get? Okay, you listen very carefully. If you have any query, you write in the chat box. Okay, if you have any doubt, you write in the chat box. Don't hesitate to write in the chat box. Okay, students, is it clear? Right. Now let us go for the continuation. Bulk or volume stress formula is what? Bulk or volume stress, any type of stress formula is same, that is force by area, right? And now this one, in this case, how we will apply the force at here? Just like this is a sphere, we can consider. Okay, ball, this you take as a sphere. On this sphere you apply the force in all directions, like this you apply the force. This force is always perpendicular to surface, and now this force acting on the surface area of the sphere. At the moment this sphere, for example, the sphere volume is decreased. Now the sphere size will be decreased. Now this is the new sphere. Initial volume is V. Okay, initial volume is V. Final volume is V minus delta V. The volume is decreased. This stress is trying to decrease the force applied on this area. Force by surface area is called as the stress. This stress is trying to decrease the volume of body, and that is called as the bulk or volume stress. Okay, and next SI unit is Newton per meter square. Next one is the Newton per meter square, or Pascal also we can write, no problem. What this stress will do, it will tries to change the volume of a body. This is about different types of stresses. Okay, generally what happening, what we discussed, the normal stresses are two types. You see here, stresses are two types. What are they? Normal stress and one more is what? This we write as A, next B. Normal stresses are two types. One is A and other one is B. Okay, right. And generally the basic stresses we classified into two types. That is, the one is normal stress and other one is the shear or tangential stress. Now one more type of stress I am going to explain, that is the second type of stress, that is the shear or tangential stress. Shear or tangential stress. The stress which changes the shape of a body without changing its size, or the stress which applied, the stress applied parallel to the surface of body, previously perpendicular to the surface, that is the normal stress. Second type of stress I will explain once again. Stresses are two types, normal stress and shear or tangential stress. Normal stresses are again two types. What are they? Longitudinal stress and volume stress. Okay, totally the stresses, if you will go for that, First, if you will, I will explain the broad classification also. Right, the stress applied parallel to the surface of a body is called as shear or tangential stress. Shear or tangential stress. Now, this force is applied parallel to the surface. That means how it will be applied. I will explain. Any stress, whatever it may be the stress, any stress formula is force by area. Okay, right. For 10 minutes, I will take the class only. I am going to close within 5 minutes. We will discuss later continuation. The stress applied parallel to the surface of a body is called as the shear or tangential stress. You see here, this is a object cylinder. For example, it is a cuboid we can take. And now this is the surface. For example, on this surface, I want to apply the force. Okay, I want to apply the force on this surface. On this surface, I want to apply the force. Okay. If you want to apply the force on this surface, then what happens? Like this, I am applying the force. This is the force. Okay, this force is act on this surface area, right? Now, this force is not perpendicular to surface. This force is parallel to the surface. Then that is called as the shear or tangential stress. Shear or tangential stress formula is force by area. Okay, any stress is same. Now, this stress, what it will do? Shear stress can change the shape of a body without change in size. This lower face is fixed and the upper face we are applying the force like this. Right? Then it will be upper surface will be displaces. This stress is called as the shear stress. Shear stress unit is also same. That is Newton per meter square. One broad classification I will tell and I will close within 2 minutes. Okay, let us see. First, stresses are two types, right now? I will give one conclusion for whatever that we discussed today, that I will explain in one step like this. This is the stress. Now the stresses are basically classified into two types, right now? What are they? First one is the normal stress. Is it right? Normal stress. The second one is what? Here are tangential stress. Normal stress means it is applied perpendicular to surface. Here are tangential stress is shear or tangential stress is applied parallel to the surface. Shear or tangential surface. Tangential stress. Tangential stress. Right. This normal stresses are again classified into two types. What are they? First one is the Longitudinal stress. Is it right? Second one is the bulk or volume stress. And the longitudinal stress is again classified into two types. Longitudinal stress is compressive, and next one is the what tensile. Okay, this is the broader classification, right? Okay, remaining we will discuss later. I'm going to close because of meeting.